All right, how are you, viewers? Right, today we want to discuss about transformation. So we have 6 types of transformation. 6 types of transformation. There are 6 of them, and they are grouped into 2 categories. The first one is congruent, and congruent means look alike. So congruent shapes. The first one we have translation, reflection, and rotation. Then on non-congruent we have enlargement, shear, and stretch. So the difference between congruent and non-congruent is that congruent, these are shapes which are equal in every respect, size and angles. The non-congruent, we have 2 shapes, the other one is bigger or the other one is smaller. But today we want to talk about translation. Right, so you have also to know that the first shape is known as what? The pre-image. That's the first shape. Then the second shape is known as image. So image, it is the second shape. Right, so right here we have 2 shapes which are drawn, describe fully the single transformation that we will map P onto Q. So P is our original shape and Q is our second shape. So this first shape P is known as pre-image, then the second shape is known as the image. All right, so on translation, how do we identify translation? So as you can see, these 2 shapes, they are all equal in sides and angles, right? So they are congruent. So the first stage to identify translation is to you have to join the corresponding points, right? Like this point and this point, they are corresponding points, they are equal, so you have to join them. So I'm joining my corresponding points, right? This one, then we also these corresponding points, this one and this one. Then I'm also joining these corresponding point, this point and this point. Okay, then I'm also joining these 2 corresponding points, they are corresponding points, so I'm joining them, right? Then I'm also joining these last corresponding points. As you can see, when you join these corresponding points, we get parallel lines. These lines, they are all parallel and they are equal in length. If you measure them, you see that these corresponding points, they are equal in length. 2 centimeters, yes, 2 centimeters, they are all equal in length. So when you join them, you notice that they are parallel lines which are equal in length. So how do we describe it? So on translation, when describing it, when you join these corresponding points and you see that they are parallel, the first stage is to write translation. Yes, translation. Then there's need now to know the translation vector. So how do we get the translation vector? So translation vector or TV is equals to ending point minus starting point. Right, so you can take, so P onto Q. So P is the starting point and Q, it is the what? The ending point. So how do you find the translation vector? So we can take any points right here. So this side is the ending point, this side is the starting point. Let's take the coordinates which plot this angle right here, or this side. So it's 2, 0. It's in the x-axis. So ending point is 2, then 0 minus the starting point. I will take what? Those same corresponding points. So I will take minus 1 and 1, minus 1 and 1. So 2 minus 1, you get what? We get 3. Then 0 minus 1, you get minus 1. So TV is equals to ending point minus starting point. So TV is equals to ending point, the coordinates are 2 and 0, minus 1 and 1. So we get what? 2 minus 2, that's 3. Then 0 minus 1, you get minus 1. That's our translation vector. Even if you take these two different points, for example, take this point minus this point. So this point is 2 and 3. Let's say you take say TV is equals to ending point minus starting point. Then take this ending point, which is 2 and what? And 3. Then write 2, 3 minus starting point. This one is minus 1 and 4. Then minus 1 and what? And 4. Right. So 2 minus 1, we still get 3. Then 3 minus 4, you still get minus 1. So it doesn't matter whether you take these points or this and this ending point and starting point, we still get the same translation vector. So translation is the movement of points and lines without changing direction. Whether you take the first these two minus this one minus this one, or this one minus this one, we still get the same translation vector. So now you have described fully the single transformation that we will map P onto Q. So the transformation is translation, and translation vector is equals to ending point minus starting point. So that's it here. So this is how you work out this question. Let's go to the other question, which is written question number 8. Right, we are given a shape. This is our Cartesian plane. Translate shape A by minus 8 minus 2. So this one is a translation vector. So you can write it down. Translation vector is equals to ending point minus starting point. Right. So we are given the translation vector now. The translation vector is minus 8 and minus 2. Then is equals to ending point. So we want to find the ending points on B. Then the starting point, we can take these coordinates right here. The first one, we can take 4 and minus 2. 4 minus 2. Then we can take 4 and 4. 4 and 4. You can also take 8 and 2. 8 and 2. And so you have how many? You have 1, 2, 3, 4, 6 and what? 6 and 4. You can take 6 and 4. Alright, let me write it down here. So you have minus 8 minus 2 is equals to the coordinates of B minus starting point, that's 4, minus 2, that's 4 and 4, that's 8 and 2. Then the last one is 6 and what? And 4. 6 and 4. Then let's make B the subject of formula. So we can say minus 8 minus 2. Then we bring this bracket here. So it's now plus 4 minus 2. So this one is what? 4 and 2, not minus 2. 4 and 2. Right? Plus 2. Then 4 and 4. Then 8 and 2. 6 and what? 6 and 4. So minus 8 plus 4. What do we get? Minus 8 plus 4. We get 4. We get minus 4. Minus 8 plus 4. Minus 4 again. Minus 8 plus 8. You get 0. Minus 8 plus 6. You get minus 2. Minus 2 plus 2. That's 0. Minus 2 plus 4. Positive 2. Minus 2 plus 2. Another 0. Minus 2 plus 4. Positive what? Positive 2. So these points made up of these points are what? Our shape, our new shape, which is what? B. So let's plot shape B. Minus 4 and 0. Minus 4 is here and 0. It's right here. Then minus 4 and 2. Minus 4 and 2. Yeah, 0 and 0. Yeah. Then minus 2 and 2. Minus 2 and 2. That's right here. So you can draw our shape here. Right, that's our shape B, which is the image of triangle A. B is the image of triangle A. So as you can see, this shape is congruent with this shape. Even we try to join these corresponding points, this one and this one, we still get some parallel lines, and these parallel lines, they are what? They are equal in length. So we are joining them to prove it. So we have joined our corresponding points. As you can see, as we are joining our corresponding points, we are getting parallel lines which are equal what? In length. So these are the coordinates of point B, and that's our shape B. Label the new shape B. Thank you so much.